Hello everyone, welcome to Physics online classes for class 11 students. Let us continue chapter 4 motion in a plane. Today we are going to derive an expression for magnitude and direction of two concurrent coplanar vectors. As we have studied in the previous class about the laws of vector addition. We studied three laws and they are triangular law, parallelogram law and polygon law of vector addition. Using the laws of vector addition, we are going to derive an expression for magnitude and direction of two concurrent coplanar vectors. Here, to derive this equation, I am going to use parallelogram law of vector addition. Now let us derive an expression. Yes, to derive an expression for magnitude and direction of two concurrent coplanar vectors, I am going to use parallelogram law of vector addition. Yes, what is the statement for parallelogram law? When two vectors of same time simultaneously at the same point represented in magnitude and direction by the two adjacent sides of a parallelogram, then the resultant is represented both in magnitude and direction by the diagonal of the parallelogram. So that law we can use to derive this expression, and this derivation carries 5 marks in your board examination. Let us derive magnitude and direction of two concurrent coplanar vectors. Yes, now let us derive an expression. We already studied parallelogram law of vector addition in the previous class. Here this derivation is very important and it carries 5 marks in your board examination. Let us derive an expression. So first I am going to consider two vectors P and Q. Vector P and vector Q are the two vectors and these two vectors are having angle theta between them. You can observe this diagram. We considered two vectors, vector P and vector Q. These two vectors are of the same type and simultaneously at the same point. You can observe both the vectors start from the same point and these are having angle theta. The angle between two vectors is theta. So now we can consider vector AB is equal to vector P and vector AD is equal to vector Q. AB gives magnitude and the arrow mark indicates direction. And similarly A to D, that gives magnitude and the arrow mark indicates direction. Now we can take a parallelogram, complete parallelogram A, B, C, D. Just we considered a parallelogram. We draw B to C and C to D to make a complete parallelogram. But only there are two vectors, vector P and vector Q. Now I am going to consider resultant vector. As we have studied about parallelogram law of vector addition in the previous class, you can remember the statement. What is the statement for parallelogram law? When two vectors of same type simultaneously from the same point in both magnitude and direction, then the resultant vector is represented both in magnitude and direction by the diagonal of the parallelogram. So where we have to consider the resultant vector in the parallelogram? We have to consider resultant vector along the diagonal of the parallelogram and which is represented by vector R. So let AC, vector AC is equal to vector R be the resultant vector. Is it clear? Vector P, vector Q. When we add these two vectors, we will get resultant vector R along diagonal of the parallelogram. Now, let us consider resultant vector R that makes an angle alpha with vector P. Observe the diagram. Angle between vector P and vector Q is theta. Now we got resultant vector R. Angle between resultant vector R and vector P is taken as alpha. Observe the diagram. Alpha is angle between vector P and vector R. Now I am going to construct a line which is perpendicular to the vector AB. So that line here I considered C to E. CE is the line I am going to construct which is perpendicular to AB. Right? What is C here? What is CE here? CE indicates the perpendicular line to the vector AB. I am going to write one equation you can observe. AC square is equal to AE square plus EC square. So you can use Pythagoras theorem here. So from the triangle ACE, see here, from the triangle AEC. This triangle you can observe. According to Pythagoras theorem, we have the equation AC square is equal to AE square plus EC square. Or we can write in place of AE square. AE square means what here? AB plus BE square plus EC square. Because you can observe A to B plus B to E. That gives AE square. AB plus BE whole square plus EC square keep as it is. Right. Then now you can use A plus B whole square equation. We know that A plus B whole square is equal to A square plus 2AB plus B square. Now I am going to write that equation here. A plus B whole square. Here this is of the form A plus B whole square, which is equal to A square plus 2AB plus B square. Here I can write A square means what here? AB square plus 2AB means AB into BE plus BE square. This is of the form A plus B whole square. Remaining is what? EC square. Then what is BE square plus EC square from the diagram? You can observe we can consider one triangle here, that is and CBE. The triangle CBE. We can take this triangle. So BE square plus EC square, in that place, see here. BC square is equal to BE square plus CE square. According to Pythagoras, we can write from the triangle. This is which triangle here? From the triangle, that is CBE. This triangle we can consider. From the triangle CBE, we can use Pythagoras theorem. So we can write BC square is equal to BE square plus CE square. Or I am going to write BE equal to, see here, I am going to write one equation BC cos theta. How we got this equation? Observe this diagram. This is angle theta, means it will be adjacent side. This is hypotenuse and this is opposite side. I want the value of BE. BE means we need adjacent side. So we can use the trigonometric functions cos theta. Cos theta equal to adjacent side divided by hypotenuse. Adjacent side is BE. Hypotenuse is what? BC. Or we can write BE equal to BC cross multiplier. BE equal to BC cos theta. Right? In place of BE, we can write BC cos theta. Similarly, one more point, CE. CE is opposite side. Opposite side means we can take the function sin theta. Sin theta equal to opposite side divided by hypotenuse. Opposite side is CE. Hypotenuse is CB. So we can write CE equal to CB sin theta. So we got the value C equal to CB, or we can write BC sin theta. Now we got the value of BE and CE from this triangle CBE. Yes. How we got this value? You can observe cos theta equal to adjacent side divided by hypotenuse. So adjacent side is BE divided by hypotenuse is BC. So we got BE equal to BC cos theta. Then second point, sine theta equal to opposite side divided by hypotenuse. So opposite side is CE, hypotenuse is BC, cross multiply. So we can write CE equal to BC sine theta. Right? So now here I am going to write, observe the equation, AB square plus 2AB capacities. This term capacities. Here, in place of BE, we can write BC cos theta. Right? Then, in place of BE square plus CE square, what to write here? BE is equal to BC cos theta plus BE square plus EC square. Here, I am going to rewrite this equation. Observe here. AB square plus 2AB capacities. BE equal to BC cos theta. We wrote in place of BE as BC cos theta plus BE square means we can write BC square cos square theta plus EC square means BC square sin square theta. Now, or we can write here AB square plus 2AB into BC cos theta capacities plus BC square, here also BC square. So we can take BC square outside. Remaining is sin square theta plus cos square theta. We know that sin square theta plus cos square theta equal to 1. So we will get this equation. AB square plus 2AB into BC cos theta plus BC square is common. Sin square theta plus cos square theta equal to 1. Leave it. So we will get this equation. AB square plus 2AB into BC cos theta plus BC square. Right? Or we can write R square equal to, in place of AC square, resultant vector AC is equal to what? Vector R. So we can write R square equal to, in place of AB, we can write P square. Observe the diagram. In place of AB, we can write P square plus 2AB. 2AB means AB is what? P. 2P. BC is equal to Q because AD and BC, these two are parallel. AD is equal to BC, so this is also vector Q. So we can write in place of BC as vector Q cos theta plus BC square equal to Q square. So we got R square equal to P square plus 2PQ cos theta plus Q square. Or we can write R equal to square root of P square plus Q square plus 2PQ cos theta. Is it clear? So this is the equation for magnitude of a resultant vector. What is the equation? R equal to square root of P square plus Q square plus 2PQ cos theta. Once again I will revise the derivation. You can observe here. We considered two vectors, vector P and vector Q. The angle between vector P and Q is theta. Let us complete the parallelogram ABCD. Here I am going to take the resultant vector R. Vector R is along the diagonal of the parallelogram AC. Vector AC is equal to vector R, that is resultant vector. Now that resultant vector R makes an angle alpha with vector P. Angle theta is between vector P and vector Q. Then angle alpha is between vector P and vector R. Now next point, we are going to construct a line which is perpendicular to the vector AB, and that line is C to E. CE is perpendicular to AB. Then we are going to consider the triangle AEC. From this triangle, we can apply Pythagoras theorem. AC square equal to AE square plus EC square. Or in place of AE square, we can write AB plus BE whole square plus EC square capacities. Now, AB plus BE whole square is of the form A plus B whole square. So, we can write AB square plus 2AB into BE plus BE square. This is of the form A plus B whole square plus EC square, keep as it is. Then, observe this point BE square plus EC square. Here, we can consider the triangle BCE. From the triangle BCE, we can apply Pythagoras theorem. So here we can write BC square equal to BE square plus EC square or CE square, right? Or we can use the side BE equal to BC cos theta and CE equal to BC sin theta. You can observe because cos theta is adjacent side by hypotenuse, so we can write BE divided by BC. Similarly, CE equal to BC sin theta. Here sin theta equal to opposite side divided by hypotenuse. So we can write CE divided by BC from this triangle. So now we can write those values here. AB square plus 2AB, keep as it is. What is the value of BE? BE is equal to BC cos theta, substitute here. Right, then remaining is BE square. In place of BE square, we can write BC square cos square theta. And similarly, in place of EC square, we can write BC square sin square theta. BC square is common, take outside, remaining is sin square theta plus cos square theta, which is equal to 1, leave it. We got the final equation AB square plus 2AB into BC cos theta plus BC square. Or we can write in the place of AC square, AC is equal to resultant vector R. So I am going to write in place of AC square as R square is equal to, in place of AB is equal to what? Vector P. So we want magnitude, so we can write P square plus 2 into AB. In place of AB, we can write vector P. In place of BC is equal to vector Q, because you can observe the diagram, the adjacent sides AD and BC. These are the adjacent sides of the parallelogram. When AD is equal to vector Q, then similarly BC is also equal to vector Q. Substitute here 2P into Q cos theta, keep as it is. BC square is equal to Q square. Substitute all the values, we got R square equal to P square plus 2PQ cos theta plus Q square. Or we can take a square root here. So therefore the final equation we can get R equal to square root of P square plus Q square plus 2PQ cos theta. So this gives the magnitude of two concurrent coplanar vectors. Yes, what is the magnitude here? R equal to square root of P square plus Q square plus 2PQ cos theta. So this is all about magnitude. Now we can derive an expression for its direction. Here I am going to consider the triangle AEC. Observe the diagram. We are going to consider the triangle AEC. From this triangle we can write the value of tan alpha. We know that the trigonometric functions sin theta is equal to opposite side divided by hypotenuse, cos theta equal to adjacent side divided by hypotenuse. So here tan theta is equal to opposite side divided by adjacent side. So we can write here from the triangle AEC, the angle alpha is here, opposite side will be CE, adjacent side is AE and AC is hypotenuse. So from the triangle AEC, I am going to write the value of tan alpha. So tan alpha is equal to opposite side divided by adjacent side. Opposite side is CE and adjacent side is AE. So we can write tan alpha equal to CE divided by AE. CE keep as it is. In place of AE, we can write AB plus BE. Right? Then CE and BE values you can observe here. BE is equal to BC cos theta. Here I am going to consider the triangle. Observe this part here from the triangle CBE. Right? This is the triangle CBE having angle theta. This will be opposite side, adjacent side, and this is hypotenuse. So now I want the value of BE and CE. So we know that BE is adjacent side, so we can take cos theta. Cos theta equal to adjacent side divided by hypotenuse. So adjacent side is BE divided by hypotenuse is BC. Cross multiply here. We will get BE equal to BC cos theta. Similarly, we want the value of CE. CE is opposite side, so we can take trigonometric function sin theta. Sin theta equal to opposite side divided by hypotenuse. Opposite side is CE divided by hypotenuse is CB. So we will write CE equal to, here CE equal to cross multiply, we will get CB sin theta. So BE equal to BC cos theta and CE equal to CB sin theta or BC sin theta. So here BE equal to BC cos theta and CE equal to CB sin theta, or we can take BC sin theta. So now let us put the values. Tan alpha equal to, what is the value of CE? CE equal to BC sin theta divided by AB, keep as it is. In place of BE, we can write BC cos theta. So therefore, tan alpha equal to, we can write this equation as, what is the value of BC? Vector BC is equal to vector Q, because AD and BC both are parallel to each other. So AD is equal to vector Q, therefore BC equal to vector Q. Substitute here. We can write Q sin theta divided by, what is the value of AB? AB is equal to vector P plus BC equal to vector Q. So after substituting all these values, we will get Q sin theta divided by P plus Q cos theta. So therefore, we want the value of alpha. Alpha equal to, this tan we can take on RHS side, it will become tan inverse. Alpha equal to tan inverse of Q sin theta divided by P plus Q cos theta. So this is an expression for direction of two concurrent coplanar vectors. We derived magnitude as well as direction of two concurrent coplanar vectors. Here alpha is direction of the vector. Now here you can observe vector P and vector Q. Vector R is the resultant vector. We used alpha, that is angle between vector P and vector R. We constructed a line CE which is perpendicular to AB. When two vectors P and Q are added, then the resultant vector will have a magnitude, that is R equal to square root of P square plus Q square plus 2PQ cos theta. This is magnitude. When we add two vectors, for example vector P and vector Q, then resultant vector will have a magnitude R equal to square root of P square plus Q square plus 2PQ cos theta. Then the resultant vector makes an angle with respect to the side AB. You can observe the diagram, the side AB and the resultant vector R. Angle between R and P is alpha. So alpha equal to, we got an expression tan inverse of Q sin theta divided by P plus Q cos theta. So this gives direction and R gives magnitude. So this is an expression for magnitude and direction of two coplanar concurrent vectors. So in the next session, we can study some special cases related to these expressions.